Alright, so if we're going to solve a differential equation, for example, like dy dx equals 4x cubed y squared, I know it's a differential equation because I have an x and a y both in my equation. And the first thing I'm going to do is separate the variables. I want to make sure x and y are on separate sides of the equation. So in order to do that, the first thing I'm going to do is multiply both sides by a dx, because anytime I can get rid of a fraction, I like to do that. So if I multiply by dx, I end up with dy equals 4x cubed y squared dx. Then the next thing I'm going to do is get rid of the y squared by dividing. So I end up with dy over y squared equals 4x cubed dx. So now I know that I can see that both of my variables are on separate sides of the equations. I have y's on this side, I only have x's on this side. So I'm in a good situation to start taking my antiderivative. Before I do that though, I want to rewrite this dy over y squared just because it's ugly. So my next step is going to be to write dy over y squared without the fraction. So I'm going to bring that y squared up, which means I'm just going to make it y to the negative 2 dy equals 4x cubed dx. Now I'm ready to take the integral of both sides. So I'm going to go in, I'm going to put in my integral sign so that anyone reading my work knows that that's what I'm doing. And then I'm going to actually find the antiderivative of both sides. So I know y to the negative 2 becomes y to the negative 1 over negative 1 plus c equals 4x to the 4th over 4 plus c. And now I'm going to simplify and solve for y. So the first thing that I can do is, since c is just a constant, I don't need it on both sides. So I can actually just eliminate the c that's over here, because if I technically, mathematically, I would be subtracting c, but if I have a constant minus another constant, I'm still going to have some kind of constant over there. So I really just need c to be on one side of my equation. So I'm working with y to the negative 1 over negative 1 equals, I can cancel these 4's too while I'm at it, x to the 4th plus c. So then I'm going to rewrite it so that I don't have a negative exponent, which is going to mean my y to the negative 1, it's going to come down to the denominator. So when I take everything out of the numerator, I have to hold that place with a 1. So then I get negative 1 y to the first power equals x to the 4th plus c. I also notice that I can rewrite this fraction as just negative 1 over y equals x to the 4th plus c. In order to get y all by itself, the next step would be multiplying by y on both sides, which is going to give me negative 1 equals y times x to the 4th plus c. And then last thing I'm going to do is divide by x to the 4th plus c on both sides, which gives me a final answer of negative 1 over x to the 4th plus c equals y. This is my general solution. General solution to my differential equation. And I know it's my general solution because of that plus c. If it still has a plus c, it's a general solution. I'm going to show you in the next video how to find a specific solution, which is where we'll get rid of the plus.